screen. Yeah. Actually, yeah, is it okay, sir?
Sir, your volume is low.
Yeah, my screen is observable, na?
Sir, volume is low, I think.
Okay.
Yes, the presentation is, I mean, we can see
Yeah.
the presentation. Probably your
Yeah.
voice is little low. So
Okay.
you
Okay.
can
Fine. Fine.
adjust your mic. Yeah.
Okay. Fine. Hello. Yeah. Is it? Just a minute. Hello. Is it audible now?
Yes, sir. It is audible. You can proceed, sir. Thank you.
Okay. Fine. 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 Yeah. Okay. So, good morning to all the participants in this particular, the ATP program. Today I am here to give a lecture, especially on the. Hello. Hello.
Hello. Yes, sir. Please continue, sir.
Okay. Okay. Fine. 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 Okay. Fine. Fine. Okay. Fine. Yeah. The content of my lecture is basically focused on the smart energy, the management system of a fuel cell hybrid electric vehicle. Now these hello. Now these are the basically the contents of my lecture. At first, the fuel cell technology, and next is the prospects and current status. Then the fuel cell hybrid electric vehicle, the configuration, and after afterwards, I would like to focus on the fuel cell hybrid electric vehicle technologies. And next one is the development of uh, energy management strategy. And afterwards, we need to focus that the how the fuel cell hybrid electric vehicle energy management strategy is developed employing the various, machine learning approaches. And then we need to investigate the various performance analysis and the studies, and lastly the conclusion. Now, firstly, while I have been emphasized on the topic that the smart energy management system of a fuel cell hybrid electric vehicle, at the very initial stage, we need to focus that how does a fuel cell technology is basically working on. Now, as we all know, basically, unlike the battery technology, the fuel cell is a kind of technology that don't run down, and it has a very higher efficiency as compared to the other generating, the resources we do have. A fuel cell basically converts chemical energy of the fuel into electricity or electrical energy that we do have actually. And a fuel cell is basically comprising of two plates separated by a membrane, which is basically known as the anode and the cathode. Now, basically, hydrogen is passed through the anode, and oxygen is passed through the cathode. At the anode, hydrogen molecules are basically splitted into electrons and protons by the catalyst. And you could see the negative particles cannot pass through the membrane, and the positive particles can pass through the membrane. and while the electrons are forced through an external circuit and generated the electricity as well as heat. So we could see that in a fuel cell technology, as per the technological advancement that we do have, as a byproduct of this chemical, the reaction, water and heat is basically introduced in this particular context. Now, if we could see that how the fuel cell is basically combining the fuels and oxidant electrochemically to produce the electricity, and the energy efficiency of a fuel cell is basically 2 to 3 times more uh, greater in comparison with an internal the combustion engine we do have. And last but not the least, the most prominent advantage of the fuel cell technology is that it has no moving parts. Therefore, the fuel cell stack is quite in operation, and this technology is so called the zero emission vehicle. Now, the next part is that the pros and cons of the fuel cell technology that we do have actually. And like all the other technologies, the fuel cell technology has some, the benefits, and also some crucial challenges that we need to face in a country like India that we do have actually. The basic advantages of the fuel cell technology is that the higher energy efficiency as compared to the internal combustion engine that we do have. And the next point is that the environmental sustainability, and that is presently the government of India is looking for that by the 2030, that the 30% of the 30% of these electric vehicles will be converted into these uh, electric vehicles technology. And as per the convention that we do have actually, that government of India whatever is planning for, that the 2030, that 30 to 40% of the conventional vehicles are transformed into the electrical transportation sector, so that we could emphasize that with the adoption of the fuel cell technology, the zero emission or net zero emission, the mission that we could be met in this particular prospect. And last but not the least, that we could see that the noise and the different sorts of the noise and environmental pollution that we need to have, that could be significantly the reduced by the employment of the fuel cell technology. But as compared to the advantages, we need to have some sort of the challenges in the coming days, as because the setup technology is basically comprising of the configuration, and the cost of the fuel cell hydrogen tank, I mean the configuration cost is so much high actually, as compared to the other energy generation system that we do have. So definitely we need to take care on this particular the context. And the second point is that the durability is also one of the important the challenges that we need to face over here, as you need to have the the different kinds of the the membranes and the catalyst uh, present over here due to the chemical the reaction takes place actually. And the third one is that the lack of hydrogen infrastructure, as because in a fuel cell tank actually, the hydrogen gas is most commonly employed fuel, or it could be available in the form of liquid or gas actually. So as per the technological prospect, it is really difficult to transport the hydrogen and to store the hydrogen in the tank, and definitely the uh, pressure of the tank that it could be maintained, and also the temperature that we need to the maintained to generate the fuel cell the technology that we need to have. So definitely in a country like India, uh, till now we are facing the lots of the challenges to introduce the fuel cell electric vehicle in the India. But we could see in the next slide that as compared to the other energy storage technologies like the different sorts of the batteries, it could be the lead acid batteries, the lithium ion batteries, the gasoline. What is the basic prospect now? Basically, in an electric vehicle or hybrid electric vehicle technology, uh, the main terminology or the technical prospect is that the energy density of the energy storage technology, as because energy storage technology is fully related with the driving condition or the running condition of an electric vehicle technology, so that during the various transient operation like starting, braking, and different acceleration, deceleration, frequent start and stop. Under this different transient environment, we need to have these, the braking energy and some sort of the kinetic energy that could be converted into the electrical and the and these electrical energy stored inside the battery, so that the 15 to 20% of the energy storage capacity by the uh, enhanced by the employment of the regenerative braking technology. And in this particular prospect, that we could see that the energy density of a hydrogen as compared to the lead acid battery and the lithium ion batteries and the gasoline, we do have that 120 megajoule per kg of the hydrogen, and it could be also further classified as 33 kilowatt hour per kg. So means per kg of the hydrogen, the energy consumption, the rather the energy handling capacity, that could be much higher per volume of the hydrogen, so that we could claim that energy density of the hydrogen, the fuel cell technology as compared to the other energy storage system, that could be much higher, and that sort of energy density could be emphasized to integrate into the hybrid electric vehicle configuration. Now the next part that I would like to introduce, that what about the fuel cell technology based hybrid electric vehicle that are introduced nowadays actually. And the fuel cell technology based electric vehicle that was fastly introduced in the country like the Japan. And we could see the fuel cell hybrid electric car that was known as Honda FCX Clarity. And Honda FCX Clarity is the fastly pioneered fuel cell hybrid car actually. And it was, as I already told you, in the Japan in the year of, I feel 2007 to 2007 to 2008, the first fuel cell hybrid car was introduced in the country like Japan. And the day by day, due to the invention of this technology, USA, California, and some other advanced countries, they have already developed the fuel cell based, the hybrid electric vehicle configuration. Now, what are the characteristics that you need to have as compared to the conventional electric vehicle, or in a battery electric vehicle? In a fuel cell, the FCX Clarity is the much integrated technology, and you could see the electrical power that could be produced over here at 100 kilowatt, and the magnitude of the torque that could be generated by the the fuel cell engine, that could be in the magnitude of 256 newton meter, and the speed could be ranges between 0 to 3056 rpm. And what the advantage is that, unlike the battery technology, it does not need any sort of this charging or discharging concept actually. So means once a fuel tank is basically filled with the hydrogen gas, and the refueling time is about only 5 to 10 minutes. Therefore, we could conclude that uh, unlike the battery electric vehicle technology, while we need to focus for the fuel cell hybrid electric vehicle technology, the refueling time is basically very lesser as compared to the charging strategy or discharging strategy in a conventional battery electric vehicle. So within 5 to 10 minutes, the entire tank of the hydrogen that could be filled over here, and during the refueling time per particular refueling, the mileage that could be taken by a fuel cell hybrid car, that could be the ranges between 72 to 77 miles per kg of the hydrogen. So now if we could see that with the addition of these, the internal combustion engine, and with this fuel cell hydrogen tank, and also with the combination of electric motor as the propulsion system, the kind of fuel cell technology, I mean an energy storage system and additional battery may also be incorporated to integrate the energy storage system, and that energy storage system is so called a hybrid energy storage system, so that the battery as well as the ultra capacitor or super capacitor must be integrated with the fuel cell technology to integrate the kind of the energy storage system, and to emphasize the range of the travel, and to reduce the range anxiety with the employment of the regenerative braking system. And these regenerative braking is one of the mandatory requirement in case of hybrid electric vehicle, rather electric vehicle configuration, and to integrate, I mean to enhance the to enhance the the distance traveled, and also to meet the different kinds of the transient, the requirements as per the different road or surface condition that an electric vehicle is supposed to possess. So in the next thing that we could see, how the fuel cell technology is basically employed in the advanced countries like the Mercedes, the Benz, and how the heavy duty electric vehicles like the fuel cell bus and the heavy duty the trucks that are basically the run in the different European states, out of which some of the cases I have taken into the example, that the Citaro fuel bus, actually it is basically made up of the Mercedes, and that bus is basically the run in the streets of the London, actually, and the engine is basically supplied by the Ballard. And this is a very large project of the fuel cell technology, which is basically showing that the 30 fuel cell the buses operating in the different parts of the country, like in the European country. And the lower figure that we could see, that the municipal bus, the model, which is basically known as the FCHB bus 2, which is basically the manufactured by the Toyota, and it is a very large bus and low floor fuel cell hybrid bus uh, technology, where the labeling that could be easily, we could see that how the high pressure hydrogen tank are placed on the the roof of the particular fuel cell the vehicles, and the hydrogen fueling the receptacles are basically introduced. And that high energy efficiency electric motors are basically coupled with the different sorts of the in-wheel configuration, and how the motion is basically transmitted to the wheels. And in this particular kind of these the hybrid fuel cell the bus, the fuel cell stacks are basically incorporated over here, and the different sorts of the fuel cell stacks that are basically comprising of proton exchange membrane, or that could be based upon phosphoric acid fuel cell, or it's a kind of, the different classification based on the fuel cell technology. And upon this technology, the US government is claiming that after running of this sort of fuel cell hybrid electric vehicle technology, this is typically the exhaust free, so that the different sorts of these greenhouse, the gases like the nitrous oxide, carbon dioxide, carbon, the monoxide, which are significantly, the minimized, so that air quality in the different urban parts of these countries has been tremendously increased, so that these fuel cell hybrid electric vehicle technology could be inventing such a promising solution to integrate the concept of the sustainable development and the green energy technology across the globe we have. Now, in the next part, actually, I have tried to show you that how an electric drive a train or powertrain technology for the fuel cell hybrid electric vehicle is configured. In this particular block diagram that you could see, this is a very interesting technology that we all the the researchers in the relevant field should be focused based on the configuration and control of the electric drivetrain technology. As we all know, in an hybrid electric vehicle, the main component of this powertrain is the electric motor, as well as the power converter and also the controller. So in a powertrain or drivetrain technology, while we do have, we definitely we definitely focused on these electric propulsion system. And electric propulsion system is basically focused on the conversion of electrical energy into mechanical energy. And in this particular technology, while we are having the fuel cell system and the different arrows or dimension that you could see, this arrow is the single arrow direction, which is clearly indicating that one way electrical linkage. And the next arrow that you could see, this arrow indicates the two-way or the bidirectional electrical communication. And this arrow is representing the two-way mechanical linkage or mechanical communication. In this particular technology, while we do have a fuel cell system and the chemical, the reaction takes place where the chemical energy of the fuel is converted into electricity or electrical energy, we definitely need to have the particular kind of these DC to DC converters. Now, DC to DC converters that we all know that the different stages of the power conversion or the power conditioning that could be takes place, and depending on the different voltage, the levels, it could be comprising of the buck converter, could be boost converter, or rather it could be comprising of the buck boost converter that we need to have. And we need to have a battery technology, so the battery should have a particular the limit of the voltages that we need to have, and the battery current and battery state of the charge is very much sensitive in this particular case while we are going to take the mathematical modeling of a fuel cell hybrid electric vehicle configuration. So in this particular case, we could see that to meet the battery voltage, we need to have the integrated power electronics converter technology. I mean the DC to DC converter technology. And if electrical motor, the classifications, everyone is basically focusing on the energy efficient electric motors. So with the advancement of these permanent magnet motor technology, presently we are focusing on the permanent magnet synchronous motor, or it could be the brushless DC motor, or it could be a switched, the reluctance motor technology. And also we may have to use the three-phase induction motor also as an electric propulsion, the motor technology. Now what we happens in between these power conditioning, we need to have a DC to AC converter, that is inverter. Now, the basically inversion is very much important, and we need to have these different different the classifications of these inverter technology and different pulse width modulation techniques like space vector pulse width, the modulation, or the sinusoidal pulse width modulation, multiple pulse width modulation techniques. So the different sorts of the pulse width modulation techniques are basically emphasized to generate the PWM pulses and to control the torque and speed of the motor. And the main mechanical quantity that we need to control is the speed and torque. The two output quantity that we need to focus, that the torque and the speed. And also, while an electrical motor is basically employed to drive the motion is transmitted to the wheels via the different transmission devices like the clutch, like the gear, you know like the electronic, the braking system that we need to have. And finally, the in-wheel motor configuration is basically employed to transmit the motion to the different sorts of the vehicles, different sorts of the wheels of these, the vehicles. And the different sorts of the vehicle accessories are basically, incorporated on the vehicle system. And in this particular context, the vehicle accessories comprising of different sorts of the sensors, different sorts of these the digital controllers. And we could see the different sorts of the thermal, the management system is one of the important parts of these configuration. As we all know that we need to reduce the heat generated in the engine, or the electric propulsion system that we need to have. So while every researchers in this relevant field would like to develop the mathematical modeling of the fuel cell hybrid electric vehicle, in this particular sort of this block diagram, we need to have a coincide mathematical modeling and to develop the fuel cell hybrid electric vehicle technology, and to emphasize the different performance characteristics of a fuel cell hybrid electric vehicle under different operating environment. Now, in the next slide, I would like to emphasize that this fuel cell hybrid electric vehicle technology we have been developed in the the MATLAB environment, and how these the mathematical modeling is basically comprising of the fuel cell, the stack module. We need to have the DC to DC converter that I have been already the described you. And it's also comprising of the battery system, and the auxiliary system is also comprising of. And the main motto of this system is that energy management system, which is the ultimate motto of my talk. Now everyone is looking for the energy management system of fuel cell hybrid electric vehicle. Energy management system is a kind of strategy by which we could manage the energy demand, energy requirement, and particular usage of the energy utilization in the different parts of the hybrid electric vehicle, so that we could say that energy efficiency could be enhanced and to meet the sustainable energy demand in a modern energy efficient environment. So in this particular kind of the strategy, the four types of electric motors are embedded in the four wheels, like the front wheel and the rear wheels of these electric vehicle configuration. And as you all know, that if each motor is basically coupled to the each wheel of this configuration, as a result, the motor speed is exactly same as that of the wheel speed, in which a manner we could conclude that the transmission losses are reduced, so that the efficiency of these the vehicles, I mean the transmission efficiency, that could be enhanced. And this rotor configuration is so-called the in-wheel, the rotor configuration, or hub motor, the configuration. And the vehicle module is basically comprising of the different performance characteristics of these, the vehicles, and a battery that must be incorporated over here. And the energy management system, we need to have the different sorts of optimal operation, and by which the some sort of artificial intelligence or the machine learning approaches that have been incorporated in the particular context to predict the particular kind of the performance of the energy management controllers. In the next case, I would like to emphasize that the energy management strategies are basically emphasized on the following necessities. Now, what are the, rationalize? The the rationalize in this context is that minimum hydrogen utilization. That is the, the first and foremost, the motto that we need to have, the, as because the less is the fuel consumption. So definitely that we could conclude that the hydrogen utilization, in a hydrogen tank, the minimal hydrogen, the gas or the liquid, as as we could maintain within a prescribed limit, so that we could maintain the hydrogen, the level inside the fuel tank that we need to have. The second one is that the overall system efficiency, that is one of the important motto, as because energy utilization and energy demand are the two very crucial factors that we need to have. And in the different parts of these hybrid electric, the vehicle configuration, and we need to maintain the losses, and as much as we could maintain the losses, so that we could enhance the energy efficiency. And the limited, the range of the batteries, that is one of the important, the motto, as because the batteries are basically designed for the particular, the limit. For an example, the battery voltage, battery capacity, battery state of the battery, battery capacity, battery efficiency, battery capacity, battery efficiency, 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 battery efficiency. Hello, hello, hello.
Hello, sir.
Yeah, 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 yeah. Uh, yeah, the next part is that the, while we must be integrating with the energy management strategy, we need to focus for the different sorts of the energy management controller. The energy management controllers are basically classified into several categories. These are known as state machine control strategy. It could be the fuzzy logic based, the strategy. Next one is the classical PI control, the method that we do have. And the fourth one is so-called the most viable control topology, which is so-called the equivalent consumption minimization strategy, and is so-called the ECMS. And the next one is so-called the MPC, that is the model predictive control that we do have. Now, while we are having the fuzzy interface system or fuzzy inference system, everyone is basically in the field of electrical or computer science. They may know that how a fuzzy inference system is basically working on. And fuzzy is basically based on some AI logic, and inside the fuzzification, defuzzification, and the rule-based fuzzy logic that we need to build up to integrate the fuzzy controller in an fuel cell hybrid electric vehicle configuration. and we need to have some sort of the inputs, and based on the inputs, the fuzzification in interfacing, and after the inference engine, we need to get the fuzzy output, and we need to have a defuzzification here, the centroid based defuzzification method that we could be incorporated over here, and the different sorts of fuzzy membership, the functions like episoidal, like the rectangular, the membership function that we could be incorporated over here, and the fuzzy rules could be implemented, the 5x5, 7x7. So the various kinds of the fuzzy rules that we could be incorporated to develop the fuzzy logic controller. Here we could see that after having the fuzzy, the rules, we could be emphasize the fuzzy plot, where we could say that the required power and the fuel cell power PFC and the state of the
Hello,
hello.
Chiranjit sir, the screen is not visible to us.
Okay, just a minute, please. Okay, just a minute, please. Yeah, is it okay now?
Yes.
Okay, fine.
Yes, now it is okay.
Okay, fine, sir. Fine. Yeah. Now, while we are having the fuzzy plot, actually, after having the fuzzification and that the defuzzification and the fuzzy logic based, the rules, the MATLAB plot is, the basically shown over here, where we could see the three kinds of the variables in a fuel cell system, that we could see the dynamic, the behavior, which are nothing but the required power, the fuel cell power PFC, and the state of the charge that we could be emphasized in this particular kind of the strategy. Now, in the next, the strategy which is so-called the state machine control strategy. This, as the name is so-called state machine control strategy. This name is basically assumed in the sense is that there is a transition from one state into the another state, and while you are having the load power and the state of the charge of the battery, this technique is basically calculating the power of the fuel cell, and the obtained, the results that we are having the sliding mode control technology. We need to get the reference electrical power, that is PFC, for the fuel cell. In this slide that we could introduce, as you all know, that the classical PI control method, as we all know, the PI, the regulator is a classical PI controller, and which is basically employed to investigate the comparative performance analysis as compared to the various advanced controller. And while the fuel cell power is low, the energy density of the battery is basically higher than the standard, and the fuel cell generates practically the full load power, especially the state of the charge is below the reference value. And here one kind of the model, one kind of the the modern controller, which is so-called a model predictive controller, which is basically a nonlinear controller, as we all know actually. And in these kinds, we could have these model predictive control, or MPC. This model predictive control is basically emphasized uh, to determine the energy management strategy of the fuel cell hybrid electric vehicle. And as we all know, in a model predictive control, while we are having the flow chart, the different process flow, for an example, firstly, we need to initiate the system state, and after having the declaration of the initial state, we need to predict the system uh, evolution or the system identification. After having the system identification, we need to go for the optimal power distribution. And while the optimal power distribution is taking place, we need to have the fast power distribution across the various parts of the fuel cell, and to measure the energy consumption across the different parts of the fuel cell. And depending on these classifications, we need to measure the energy consumption and the constraints of the model identification. And finally, we need to repeat the the prediction or uncertainties, whatever the control variables or constraints in this context that we need to have. And finally, we need to get the output variables by employing the model predictive control strategy. Here, the manipulated here we could see the manipulated variables are basically power needed for the fuel cell, demand for power to the battery, dissipated power we need to have, and the controlled variable in this context is the developed power and the state of the charge of the battery that we need to have. Now, the next part is one of the important kind of the controller that is known as the sliding mode co-controller. As we all know that the sliding mode control is one of the the robust and the nonlinear control strategy that we need to have, and it is basically employed to create a sliding surface, and the path is basically forced to stay on a particular surface actually. And it is basically the design to have the robustness against the uncertainties and some sort of the disturbances inside the control action that we need to have. As a result, sliding mode control action possesses first response first the response characteristics, rapid adjustment or adaptation to the environment,
Hello.
or the hello
Hello. Sir.
hello
Sir,
hello
your
yeah.
screen is not visible.
Oh, but I have already shared my screen actually.
Uh,
I have already shared my screen. I don't
Sir, kindly
know.
reset.
Yeah, please. Now,
Yes.
is it okay?
Yeah, fine, sir. Yes, sir, fine.
Okay, fine.
Uh,
Yeah. Yeah, the sliding mode control strategy is one of the important and the robust kind of the nonlinear control strategy that we do have actually. And these employing the sliding mode control strategy, we need to provide the robustness, eh, you know, against the some sort of the uncertainties and the disturbances that we need to have. And sliding mode control strategy possesses the first the response time, the rapid adjustment that we need to have. And this control strategy is designed to meet the changing driving condition under the various operating environment, to meet the optimal energy management strategy that we need to have. And whatever the different power flow, I mean the process flow diagram that we need to have to design the sliding mode control strategy. Firstly, we need to have this sliding surface, and we need to measure the system state. While we measuring the system state, we need to compute the control input. And while we are having the desired control input, we need to apply this control input to update or to uh, update the system dynamics by which the system could be identified. And upon that, the checking process is going to be continued on the sliding surface. And finally, we need to get the output variables or the characteristics, which is truly the robust in need as compared to the classical control or the PI control and other kinds of the control technology that we need to have. And as compared to the other control topologies, firstly, we need to, as per the theme of these FDP is concerned, that we need to go for the machine learning approaches. Now, basically, the machine learning is basically a kind of artificial intelligence or subset of the artificial intelligence technologies, and the different, machine learning approaches are employed in this context to predict the energy management strategy or the performance of this optimal performance of the fuel cell hybrid electric vehicle under different operating environment. Now, while we are having these different sorts of these, the machine learning approaches, here are the some of the particular key technologies by which the machine learning could be employed. And the machine learnings are basically classified into different categories like supervised learning, unsupervised learning, and reinforcement learning, depending on the different dimension of the data sets or the predictive behavior of the different sorts of the systems or the data set that we need to have. In this particular context, the predictive energy management is one of the important aspects by which the machine learning could be employed. The route planning, I mean, the route planning, I mean, in this particular context, while we need to have the focus on the different power flow paths of these different configuration of the fuel cell hybrid electric vehicle, and in that particular kind of the strategy, the performance of the various controller has to be specified, and we need to choose the best performance of the controller. And by choosing or selecting the particular kind of the controllers, we need to predict the future behavior or the predictive behavior of this particular kind of the energy management controller. And the health monitoring of the fuel cell, and this is one of the important aspect, as because while our typical fuel cell stack is basically embedded on the fuel cell hybrid electric vehicle, so different dimension of the fuel cell technology we need to monitor, like the temperature, like the fuel cell, I mean the inside the tank pressure, the battery SOC, the state of the charge that we need to have, the tank uh, battery, I mean the fuel tank size, fuel tank capacity that we need to have, and finally the emission control that we need to have, as because uh, environmental sustainability is one of the critical the context to maintain the energy demand, energy requirement, and efficient energy utilization in the different parts of the fuel cell hybrid electric vehicle. So therefore, the machine learning approaches are basically employed to focus this sort of particular key, the technologies by which every researchers could have the provision to integrate their kind of the energy management strategy by which the environmental sustainability that could be made by the by the uh, any the government or any researchers or any practicing engineers are basically looking for. Now, while implementing the machine learning concept, we are all know that what are the basic steps actually to integrate a quality machine learning algorithm. Firstly, we need to capture an exhaustive data sets. The data sets are very much vital, and we need to collect the adequate number of the data sets to fetch the machine learning algorithm. After fetching the data set, we need to have the training of the data set. The training or learning of the data set is very much, very much sensitive, as because the machine has to train or learn the, the model or the, the different sorts of the data that are, the looking for. After training the data set, this particular, the data set should be learning. I mean, the learning algorithm we need to focus for. After having the learning, we need to have a trained algorithm. And while the trained algorithm is basically made up of, we need to forecast, or we need to um, we need to we need to emphasize the future, or uh, predictive behavior, or to forecasting the forecasting the future behavior, or for the optimal the operation of any sort of the the data set, or any sort of the system that we are looking for. Now, in this, the before implementing the machine learning algorithm, one of my PhD scholar is basically working on the fuel cell hybrid electric vehicle real time, the data set. That the data set, I mean, the real time system on the fuel cell hybrid electric vehicle is basically captured in this particular context. Here we could see the different components are basically embedded on the experimental test bench, where the test bench is basically comprising of the different load emulator, controller, power electronics converter, different parts of the sensing unit, different parts of the controller, and a monitoring unit that we could be placed over here. In this context, a real-time controller, that is WCU300, that particular kind of control toolbox is basically incorporated to implement the real-time control algorithm of a fuel cell hybrid electric vehicle. And in the right hand side, we could see the internal layout of this particular kind of this experimental test bench that we could see here. The particular kind of the load emulator is the three-phase induction motor, and this particular kind of this induction motor is basically employed to generate the electromechanical power conversion. And we could see there are basically the different kinds of the sensors and different kinds of the controller, and the real-time communication could be taking place to capture the real-time the data set by employing in a hybrid electric vehicle configuration. And by implementing the real-time controller, we have captured the different sorts of the the real world driving the data set. And after having these the real time control uh, experimental test the rig, we have been captured the different parts of these the performance uh, context. Here, as we have been applied the MPC control, the CMS control, the sliding mode control, fuzzy logic control, and the PI control. And we could see the four classifications, like the battery state of the charge, hydrogen consumption, overall efficiency, and the battery stress. The four important parameters are basically classified to expedite the process of these, the real-time performance specifications of a particular fuel cell hybrid electric vehicle configuration. And in this context, while we are having this comparative performance analysis, we could see that MPC control strategy, that is the model predictive control, and the sliding mode control strategy, that we could see the better performance specifications in terms of the battery state of the charge, overall efficiency is one of the important criteria that we could have been taken into the consideration. And depending on that, the selection of the controller, for an example, under which the machine learning approaches could be emphasized to select the particular kind of the control strategy and to predict the future behavior of this particular energy management strategy that we are looking for. Here you could see the different, the machine learning approaches, like the support vector, the machine classifier fusion technique, k nearest, the neighbor, naive Bayes algorithm, and last one is the most important and sensitive machine learning approach, which is so-called the by LSTM approach. These are the classifications of the several, the machine learning approaches have been employed to select the particular kind of the energy, the management controller. Now, upon classification, we could see the one of the most important kind of the classification is the SBM, or it is so-called the support vector, the machine. Support vector machine is a kind of supervised, the machine learning approaches, and which is basically employed for the both classification as well as regression. And in this particular context, optimal hyperlane in the different classes are expected to have, and this classification is based on to match the closest data points to the hyperlane. And as per the classification is concerned, the memory is efficient as it uses a subset of the training points in the the decision function called the support vectors. So therefore, the training of this data set, we need to have the feature extraction. After having the feature extraction, the training system is basically employed by using the extracted features. Then afterwards, SBM classification could be taking place. After this SBM classification, we need to have a testing of these data set, and after testing of these, the data set, we need to get the final feature extraction to expedite the predictive, the nature of this energy management controller. Here we could see the by the employment of the SBM algorithm, the different parts, the different features of this, the data set, and as a result, the accuracy that we could take, that the battery capacity and battery stress, while we take, the accuracy could be emphasized as 95%. The 90% only. And additionally, while the range of EV mode is added to this context, accuracy to enhance to 95%. And in the last case, additionally, while the fuel tank capacity is added to the battery capacity, battery stress, and the range of the EV mode, the accuracy could be enhanced to 98%. In this context, we could emphasize that as number of the feature vectors are basically increasing, so that the accuracy of this particular testing data set that could be enhanced in proportion accordingly. Now here you could see that the selection of the feature vectors, how the selection could be taking place by employing the different feature vector set. Here, while implementing the different feature vector set, we need to have these different classifications of the features, like the battery capacity, battery stress, the range, EV mode, fuel tank capacity, mass, actual fuel, actual fuel economy, aerodynamic drag or aerodynamic force, and the slow charge max. So therefore, the feature symbols are basically classified as F1 to F8 respectively. And while we are going to rank the feature vector set, we need to be focused that how the classifications for the optimal features is going to be classified. Based on this, the range of this EV mode, that is the F3 mode, is ranked as the one feature vector set. The battery stress is classified as number 2, and correspondingly we are gradually we are ranking the feature vector set employing the capacity of these different features, and finally we could take the slow charge, actually the number 8 feature vector set, and correspondingly we are combining the feature vector set like the different the matrix or the nature that we need to have, and the feature vector set are classified by um, using these the matrix, and they are classified as M to Z in this particular context. And while we are having the the measurement of the accuracy with the incremental feature vector set having the comparison of the different the machine learning approaches like the SBM, K nearest, the neighbor, naive bias, and the classifier fusion technique, we need to have a measurement. I mean, the comparative performance analysis of this, these classifier fusion technique as compared to the SBM, KNN, and the naive bias algorithm. The accuracy that could be a measurement by which the incremental feature vector set that could be selected to test the particular accuracy of this the data set. And here the among kind of the classifier, while we are having a hybrid classifier, that we could see the comparative analysis in a bar the diagram, that we could see the while we are having the SBM, KNN, the naive bias, and the hybrid classifier, the percentage that in a hybrid classifier, that hybrid classifier is basically emphasizing the superior performance in terms of sensitivity, specificity, as well as accuracy. Mm, Therefore, we could conclude that as compared to the standalone SBM, KNN, and naive bias machine learning approaches, hybrid classifier is basically possesses the higher performance amongst the all the existing the ML approaches. The next part is the ANOVA test. As you all know, while the analysis of the variance or the box plot is basically possesses mm, that the analysis of the variance, I mean the statistical analysis of the the data set having the different feature vector set we need to have, and upon the different classifications of the machine learning algorithm, while this algorithm is tested in the MATLAB environment, we could see that number 3, 1, 2, 3, 4, the 4 number of the feature vector sets are available in this particular context. And in this context, it is clearly observable that the feature vector number 3 is having the more statistical significance as compared to the other feature vector sets are available in this box plot, the nature, and which is clearly indicating the analysis of the variance under this particular and the under this particular the machine learning algorithm. Now the next part is the cross validation. The cross validation technique that we have, after having the cross validation, the different functions like the linear, polynomial, and the RBF functions are basically the radial basis functions, and we could be able to measure the accuracy, and the different subsets are basically introduced, and after having these subsets and the kernel function, we could see the polynomial functions is having the highest accuracy, that is 98%. And as compared to the other other machine learning approaches, I would like to emphasize based on the by LSTM method. By LSTM method, which is so called bi-directional long short time, the memory. This is one of the significant machine learning approaches as compared to the other existing machine learning approaches that we do have. And this work we have been already implemented as an outcome of my PhD scholar work actually. It is by LSTM, or rather LSTM is a kind of artificial recurrent neural network technology, and it is a subset of the deep learning across the various fields. And this method is basically employed due to its proficiency uh, in the capturing the long-term dependencies. And it is basically so-called bi-directional long short-time memory, in the sense is that the first LSTM is basically handles the original sequence in the forward direction, and the second LSTM is basically operates on a backward direction of the input. Therefore, this approach enhances the model's capability to grab the information from both the past as well as the future, thereby refining its proficiency in analyzing the sequences. So therefore, while implementing the bi-LSTM energy management system, we need to have the data normalization. And after having the normalization of the data, the testing, the training or learning of the data set that should be focused. After learning or training of the data set, we need to have an optimized by LSTM model, and the reconstruction of these by LSTM, the model comprising of the two kinds of controller, that is the MPC and the sliding mode controller. And we need to check the accuracy, and depending on the classifications, we need to check the accuracy of these two kinds of these superior controller, like the MPC and the sliding mode controller. And finally, we need to predict the optimal optimal uh, optimal behavior of this kind of the energy, the management controller. Now, as compared to these earlier techniques, in these by LSTM approaches, we are the gradually capturing the different kinds of the feature extraction, and also we have been ranked the different kinds of the feature vectors from 1 to 10 subsequently. And finally, we are having to get a results to emphasize the range of the EV mode, actually the different, the range or the distance traveled by an hybrid electric vehicle. And the battery stress is basically plotted in the x-axis, and the y-axis is basically, the representing the various, the range of the EV mode that we could be seen, that in a under different surface condition or different environmental condition, and different transient natures of these hybrid electric vehicle, depending on these various road surface condition, we could be able to predict the distance traveled or the running performance by an hybrid electric vehicle very easily, and we could be able to plot these sorts of these predictive, the nature or the behavior. Here we could see the after having this, the machine learning in the MATLAB, we could be able to check the accuracy and the losses after having this subsequence of this training, testing, and validation processes. And we could be able to get the validation accuracy that about 98.1%. And we could see the accuracy and the losses that could also be the measured in this context. And finally we need to have a confusion matrix. This confusion matrix is this this confusion matrix is a consequence of this particular kind of this training, the training data set and the testing data set, by which we could be able to get the different classifications like true positive, true negative, false positive, false the negative. And after having this true class, and we could be able to get the predictive class as well as the losses and the sensitivity that we also could be checking over here. And in this particular context, the diagonally that we could see the 78, 77. So this value 70 78, the numeric value is basically the representing the true positive magnitude. 77 is the true negative magnitude that we need to have. The uh, false positive and the false the negative, that diagonal value that we need to classify. And the losses that we need to have, the loss is about 3.7%, and we could be classified as a class as 0 and 1. And while we need to have the accuracy could be measured in the ratio of true positive plus true negative divided by all. And the sensitivity that could be measured as 100% sensitivity, which is classified as the ratio of true positive divided by true positive plus false positive, which is clearly significant as 100%. And specificity is also could be classified as true negative divided by true negative plus false positive. So therefore, by employing the confusion matrix, we need to have the computational accuracy, which in terms clearly determining the performance of the training data set and the testing data set in terms of the sensitivity, accuracy, recall, losses, specificity. And while having this performance analysis, and we could see the precision and the sensitivity by employing the different subset of these the machine learning approaches. And finally we need to have the by LSTM approaches, where the magnitude of this precision that could be taken over here as 92.3%, and the sensitivity is 100% in comparison to the other the machine learning approaches like the KNN, naive Bayes, and the support vector the machine we are having. And while we are having the comparative performance analysis, employing the different parameters like the hydrogen consumption, overall efficiency, the battery stress, we are having a comparative performance identification, while we need to get the particular energy management strategy, having the different performance specifications by which we could be able to comply that the model predictive control strategy and the state machine control strategy, fuzzy logic control strategy, PI control strategy in terms of the hydrogen consumption, overall efficiency, and the battery stress, that also could be investigated to justify the credibility of the particular energy management strategy under different operating environment. Now it is also a kind of performance analysis by which we could be able to plot the average fuel economy and also the peak power the requirement under various driving environment that we could be easily investigated. And finally, while we are having the different features actually, and we need to get the accuracy employing the different sorts of the test, the data set that we could be confirmed that while we are having the battery capacity, battery stress, and the range of these EV mode, additionally, the fuel tank capacity is taken into the consideration. The accuracy of this test data set could be lies to 98%, having the incremental feature selection criteria under this strategy, and correspondingly we could see that the box plot nature that we could easily able to emphasize that the number 3 feature vector set having the more statistical analysis as compared to the 1, 2, and 4 feature vector set. Therefore, the analysis of these variance that could easily investigated by employing the box plot under this, the machine learning approaches. And while finally we could be able to conclude this particular kind of this energy management strategy, employing these machine learning algorithms that we need to have, that energy management strategy is one of the important and sensitive strategy nowadays in the electromobility solution to meet the integrated sustainable energy environment. And also energy management strategy is basically comprising of energy demand, energy requirement, and energy utilization in a very effective manner, so that in a fuel cell hybrid electric vehicle, while any researchers or practicing engineers or industry is looking for to develop the energy management strategy, various kinds of the artificial intelligence algorithm, or rather a subset of these machine learning approaches are very much crucial to determine the predictive behavior and to select the particular kind of controller under this energy management strategy. And this energy management controller is basically based on the various kinds of these controller, like the classical PI control, like state, the machine control, like sliding mode control, like the model predictive control, like the fuzzy logic control, like the ECMS strategy. And these energy management controllers, we have to check the performance employing the real-time driving data set. And while we are having the real-time driving data set, we need to have a comparative performance analysis of this data set in a standard operating environment. Therefore, we need to select the classifications of the controllers, and while we could select the particular kind of the controllers, we need to have the machine learning approaches. Under this strategy, we could conclude that by LSTM model is a kind of prominent and effective approach to deal with the different sorts of these difficulties. Additionally, to optimize the energy utilization in the dynamic and uncertain driving environment. Furthermore, while considering the different performance indicators of this energy management strategy, like the mass, battery capacity, range of the EV mode, the fuel tank capacity, battery stress, energy consumption, these are the dynamic variables that, or we could say, the data set. Now, someone may ask you, may ask actually, someone is having the query that how these how these kinds of the parameters are basically taken into consideration to integrate the energy management system of a fuel cell hybrid electric vehicle. First and foremost criteria is that you need to have an exhaustive data set. Without having some sort of this exhaustive data set, we cannot able to comply with these machine learning approaches, because we could not have these adequate data set by which the training and testing could be taking place. And if we could not able to training and testing these adequate the data set, we could not able to predict the future behavior or the predictive behavior of this particular kind of the energy management controller. Therefore, under this investigation, different performance specifications we need to capture, like the fuel cell efficiency, like the range of the battery, like the battery tank, I mean the fuel tank uh, capacity, energy, the consumption, and finally, this energy management system seamlessly integrating with the vehicle dynamics. Vehicle dynamics in the sense is that we need to go for the different dynamic behavior, like the aerodynamic drag or force, that the drag coefficient, and we need to have the vehicle and the body weight, that we need to have the acceleration, deceleration, the total distance covered, the speed, and the different profiles that we need to optimize to obtain the overall efficiency of the hybrid powertrain technology. And uh, lastly, I would like to emphasize that by optimizing the utilization of the fuel cell and the battery, the bi-LSTM model could be able to contribute to reduce the environmental impact of the fuel cell electric vehicle. As a result, we could be able to lower the emissions, and finally, overall sustainability could be achieved in this context. Now, as a country like the Indian, the government is basically focusing to integrate the electric mobility solution and to reduce the carbon footprint by the 2030. The pledge has been taken that 33 to 35% of the conventional vehicles are basically transformed into the electric vehicles technology, and different public and private sector agencies, these are basically making a joint collaboration to integrate the different charging infrastructure across the various parts of these countries to share the non-fossil fuel based electricity by the 40% by the 2030. And also I would like to emphasize that with the incorporation of the sustainable energy technologies like the solar energy, wind energy, biomass energy, wave energy, tidal energy, these sorts of sustainable energy resources could be in the electric mobility solution. And there is an uh, uh, integration with the electric grid, by which the vehicle to grid and the grid to vehicle, this sort of these technology could be emphasized to meet the different needs of the customers, consumers, and different needs of these power plant, the engineers, and also the cost of the electricity generated, that is the per unit of the electricity generated, so that in a deregulated electricity environment, by this context, different governments, especially the Indian government, is basically looking for to integrate this non-fossil fuel technology in the field of electric mobility solution. And fuel cell technology is one of the most promising technology in the coming days in a country like India, to integrate the concept of the hybrid electric vehicle technology in a smart city infrastructure that also we are looking for in this present context. And these are some of my, the references where I would like to emphasize that in this context, some few of my scholars that are uh, basically published the papers. The first one, the paper is efficient energy management strategy for fuel cell hybrid electric vehicle using classifier fusion technique. And this paper has been published in IEEE Access in the the last year. The second paper of us actually, this is so-called efficient and phase driven power extraction and control strategies for the photovoltaic BESS integrated electric vehicle charging station. This paper has been published in the Renewable Energy Focus Elsevier. The third paper of us, which is basically comprising of by LSTM predictive control based efficient energy management system for a fuel cell hybrid electric vehicle, and it has been published in the sustainable energy grids and networks Elsevier in this year exactly. And the fourth one, that is basically classified as SBM classifier based energy management strategy for dual cell fuel cell hybrid electric vehicle. It has been published in the IET Journal of the Engineering. And the last one is also of our latest work, and that is comprising of an enhanced approach for solar photovoltaic based grid integrated hybrid electric vehicle charging station, that is published in the international the Journal of Energy Research Willy in this year. And these are some of my collaborative the research work in this relevant field where I have been already focused on. And lastly, I would like to thank you everyone uh, for your the kind presence and the listening. If you are having any sort of the queries, you may please ask me.
Hello, sir.
Hello,
Thank you,
yeah.
sir. Thank you so much for sharing your valuable knowledge and experience. We
Okay.
hope all the participants learn a lot from this session and it will be really helpful for them. I am requesting every participant, if you have any question, please you can raise your hands and ask one by one. Please turn on your mic and start your questions.
Hello, am I audible, sir?
Yeah. Please.
Sir, firstly, I would like to thank you for such exhaustive and wonderful presentation, sir. I have a very basic question, sir. Nowadays, we know that as opposed to the lithium-ion batteries, where the chances of means capacity fade or degradation is very significant. But in case of hydrogen fuel cells, I think that it is very means good as opposed to lithium-ion, because there is in a material aspect we don't know what's happening inside the black box. But in case of fuel cells, energy storage, it's just a hydrogen and oxygen, just output is water. And also, sir, I would like to ask first question that as you mentioned the SOC, in case of batteries, we say SOC is remaining amount of coulombs divided by total coulombs. But in case of hydrogen, what is SOC as you mentioned? And the second question is that
Yeah. Good. Yeah.
uh, Yes, sir. In case of second question, sir, if there are lots of stack of hydrogen fuel cells in a vehicle, and as well as you also mentioned in a hybrid case, there's a batteries and other things, then how it
Yeah.
is possible to manage, means how to means simultaneously calculate the each cell
Yeah, I see.
OCV as well as to means using algorithm like ANN, how it
Yeah,
is
yeah.
possible to manage lithium and batteries as well as fuel cells.
Okay, I see. I see. I see. I
Yes,
see.
thank
Okay,
you.
okay, 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 okay. Yeah.
Thank you, sir.
Yeah, look, actually, as compared to the battery electric, the vehicle, while we are having a fuel cell hybrid electric vehicle, the fuel cell is the main source of energy generation. But additionally, as an auxiliary system or auxiliary energy storage system, we need to have a battery, as because while this technology is known as the hybrid energy storage technology, uh, uh, as because uh, the battery is basically incorporated additionally as an auxiliary source in comparison with the fuel cell, because you need to have this concept of the regenerative braking operation in an hybrid electric vehicle configuration. And sometimes, instead of the battery, ultra capacitor or super capacitor may also be integrated with the fuel cell technology. And battery, as you all know, battery is the prime source or the very conventional source of the energy storage technology that we need to have. So what happens actually, depending upon the classification of the battery, it could be the lead acid battery or the nickel cadmium battery, or it could be the lithium ion the battery. You need to select the battery SOC, as because the battery is basically taken over here in this particular context, that the additionally you need to integrate the battery with the fuel cell. Exactly. As because only fuel cell cannot be taken as the energy storage. Fuel cell is basically employing for the energy generation. And additionally, while the hydrogen gas is basically filled inside the storage tank, you need to maintain the level of the hydrogen, the inside the hydrogen tank, you need to maintain the temperature, and also the thermal management system is one of the important management by which you need to have a the radiator and the coolant that you need to have to maintain the engine temperature actually. Additionally, regenerative braking, this is a mandatory requirement in case of a electric vehicle or hybrid electric vehicle, by which I would like to emphasize you that the different power converters and especially the controllers that must be integrated in the powertrain technology, that you need to have the concept of regeneration. Without the impact of regeneration or regenerative braking, you cannot have a control of the energy storage system, that is the recovery of the energy. And as an impact of the regenerative braking, we could conclude that 15 to 20% of the energy capacity that could be enhanced and is basically restored in the battery, by which the range or the driving anxiety that could be enhanced by the employment of the fuel cell hybrid electric vehicle configuration. Got my point?
Seriously. Thank you so much, sir.
Okay, okay. If anybody is having more query, you may please ask me.
Hello, sir. I think everyone is clarified.
Okay,
Sir, with your permission, if you allow us so that we can take a group photo.
yeah, please.
Okay, sir. Thank you, sir. So I am requesting every participant, please turn your on your camera so that we can take a group photo.
Thank you, Professor Chiranjit, for this insightful talk. And obviously, I believe this will help a lot to those participants, those who are here, even though it is Sunday. So, yeah,
Yeah,
certainly
yeah,
it
yeah.
is
Really, 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 really.
Sunday for you to
Most,
I beg your apology,
most.
not, I mean, not for allowing you to spend your valuable time with your family. So, whatever. Uh, we are the voice of completion of this session today. So we will be having the next session at 2:15. So it's a good thing that at around before 1 o'clock itself the session has been completed, and after this group photograph we can be able to move at for our lunch. So I'll be asking my volunteers to confirm whether the photograph has been captured or not. Thank you very much, all the participants and Professor Chiranjit for being with us. So there will be a break for 1 hour at sharp 2:15. We will be having our next session. So our next speaker is Dr. Sanjay Levarma, who is from IIT Meghalaya. So I'll be sharing the topic of that professor in the WhatsApp group. So hope all of you will be joining post lunch. Thank you very much.
Thank you all.